do what it needs to do. Bear with me a sec. If you guys could just let me know when you're seeing the slides. Are they up yet?
Yes, they are.
Yes.
Excellent. Thank you very much.
Hello, Dermot,
so,
the mystery Dermot. There you are.
Good evening. This is me. Yes, for better or for worse. Here you go. I hope I won't bore you all to death. I'm going to follow up on some of the inspiring subjects and aspects of Sarah's talk. You got a really good exposition there to the nuts and bolts. I'm going to try and give a little bit of theory, some nuts and bolts, and hopefully leave you with some key takeaways. I'm going to rattle through fairly quickly. If you could just please keep a note of any questions you have. I'm going to try to leave a little bit of time at the end for us to discuss things. So this is what I'm going to try and speak about this evening. So a super quick introduction to the context of this and why it's important. I'm probably going to skip over regulations and harsh realities and just move on to nuts and bolts, which is to say the components of an energy efficient home. I'm going to speak a little bit, following up on what Sarah said about some of the materials that people choose and why it matters in terms of insulation. And then just give you some examples of the various elements of the building and how they are typically treated. And I'll also finish with 2 or 3 slides speaking about some deep retrofit work that I've been doing over the last year for the London Borough of Sutton, where we've got some zero carbon retrofits going on. So let me move on. So just in terms of context, you know, we know that we've got a major environmental catastrophe around the corner. And one of the ways we're going to overcome that, in fact, you know, the only realistic way we're going to address that is if we successfully address the residential sector, which you can see here is about 30% of the UK emissions. So it's unavoidable that we deal with this. We just need to develop intelligent and cost-effective ways of doing it. And that's, of course, why we haven't done it so far. This is just talking about the way the building works and how much energy is typically used in a building and where it's used. So if you look at the left-hand side, the bigger pie chart, the big figure to think about really is the space heating. It's 60-odd% of the energy we use is for space heating. Interestingly, in future, with global warming happening the way it is happening, we will also have another dynamic to deal with in the future, which is not to say space heating, but space cooling. And that's also why it's really important that when we retrofit, we retrofit not just for today's needs, but for future anticipated needs. And these are you know, realistic climate predictions that will require us to be cooling our homes in the future. So after the space heating, it's 17 or 18% that runs into the hot water that you use. And all the other elements are relatively minor in the equation. I'm going to just move us on to the next slide because it's a slightly better illustration of what you've got on the right-hand side, the smaller pie chart. And that's really talking about heat loss in your home. Now, this is a really old slide from, I think, the 80s by the Energy Savings Trust, and it looks at the typical heat loss within an average terraced house. Clearly, this is a very average representation, and houses vary widely, despite looking the same. End of terrace, mid-terrace, halls adjoining, all have different dynamics. But in broad terms, you know, 25 to 30% of the heat gets lost through your roof, around about another 30 to 35% through your walls. Floors can be anywhere between 8 and 10%, sometimes higher, and then your windows and doors are the balance. So when you target the work to your building, your retrofit work, it's really, really helpful to bear these principles in mind. And there's lots of low-hanging fruit, for example, in your loft. So moving on, this is really just a context for the journey that we're on, we need to develop a zero carbon strategy for all of our homes, which really means that everything bar conservation area at the lower end or listed at the higher end, building retrofit needs to deliver vast improvements. So if you just look at the building stock average at the moment, it's 250 kilowatt hours per square meter per annum. And where we need to get to is something that's closer to 15 kilowatt hours per square meter per year. So, you know, there's lots of different ways of measuring this and looking at these things, but we do have quite a long journey to go on. So as Sarah said, the starting point really is insulation. You need to start by reducing the heat demand primarily in your home, but the energy demand overall. And the way you do that is by simply reducing the speed at which temperature loss occurs and heat loss occurs in your building. And of course, also, as Sarah said, restricting wind and air flow into the building to control it so that you don't have drafts. And I suppose this particular graphic is really just intended to let you know that there's more to think about when you're choosing your retrofit products than simply meets the eye. So we had a comment earlier speaking about the different kinds of insulation materials, a question that made us think, you know, what materials are the right materials for buildings and whether buildings need to breathe or they don't need to breathe, and how you control them and manage that. So this all feeds into this kind of loop of what kinds of considerations you need to bear in mind when you choose an insulant. And all materials are not made equal. You can't square the circle. This is a circle, and you need to think about it. Now, I'm not going to spend all evening here talking about material considerations, but you do need to consider them, and whoever's advising you professionally needs to be able to justify why their materials are the right materials for your home. And just make sure if you come away with one thing, or one of the things you should come away with this evening, ask your builder, ask your advisor how they can justify their proposed solutions. And, you know, what does that mean? It means that insulants have got all kinds of off-gassing issues. They've got mold growth potential issues. There's fire and intensity of fire and fumes from fire. There's acoustic considerations. And last but not least, in the light of climate change, there is summer overheating considerations. Indirect health issues, obviously, to do with the impact on the environment from the manufacture and disposal of the materials you use. All these things have to be part of the consideration. And just in case people think overheating isn't a problem, it's one of the biggest single worry points at the moment for example, the Climate Change Committee recently wrote about the need to adapt buildings. We're not just talking about mitigation, we're talking about how buildings will work for a changing climate. And overheating is prime among those considerations. So into some nuts and bolts very quickly. So here are some pictures of some loft. I'm sure lots of people have seen lots of lofts before, but you know, the left-hand solution just shows you some, in this case, some sheep's wool, but also shows you some rigid storage platforms using wood fiber that allow for you to store what you need in your loft. It's important when you store in a loft, you don't store on the top of a flexible insulant because that compresses it and minimizes its thermal performance. Sarah also spoke about working in roofs where you don't have a loft, and this is basically insulating in the line of the rafters. A couple of pictures here of different applications of that, where you're underneath existing plasterboard or inside the line of the rafter working. Floor insulation ideally works such that it is an airtightness layer, you know, so you're preventing drafts, but you're also providing the means for heat loss to be reduced. And this is a schematic, a super basic drawing showing how that's possible when you do it thoroughly with a membrane, which sort of tucks up behind your skirting boards around the room, as well as the insulation below. And this is the sort of less expensive way of doing it, using a kind of a bird mesh underneath a suspended floor, and lots of, in this case, lots of sheep's wool lodged in between the rafters, or excuse me, the floor joists, and ensuring also that there is, as Sarah said earlier, the critical airflow is maintained below the floor. This is an external wall insulation project midway through, just before it receives its external breathable render, which is in the case of this particular project was a lime-based render. And this project, which we did about 10, maybe 12 years ago, was also a cavity wall building, and we had installed a cavity wall insulation as well as an external wall insulation. This is just another example, an interesting example that you have to think about, because when you're extending on a gable side of a building, on an end of terrace, you've got to extend your roof. So you need new tiles, as you can see here, that come over the insulation layer. And that is that same building finished with new soffits and insulation rendered. Considerations when you look at any building, and these are some that we looked at for Haringey Council probably again about 10 years ago, and you look at all of the hodgepodge history of drainage. When you want to insulate that wall, you'd have to take all those drainage pipes off and rerun them, and that adds thousands of pounds to a project. So really needs thinking and planning and careful budgeting. So here's some internal wall, I beg your pardon, internal wall insulation. On that left-hand photograph, you're seeing a party wall. Somebody asked about party wall insulation. So on the right-hand side, you're seeing, of that left-hand picture, you're seeing a party wall with a neighbor and a chimney breast insulated for acoustic as well as thermal loss reasons. And on the front in the bay, you're seeing that same insulant with a plaster on top of it. So you're seeing two stages of the same process. On the right-hand side there, you're seeing an air tightness membrane that has been applied over an insulation layer, and then on top of it, a wood fiber, a tongue and groove wood finish that was applied instead of plasterboards in this particular case. So I'm going to finish with three slides, I think it is, possibly four, three. Which just gives you some sort of up-to-date headline data around some social housing decarbonisation work, which I'm involved with. These pictures in the following slides are of a pilot scheme of 5 houses, which are just completing, or have just completed about 3 months back now, in London Borough of Sutton. And this is just to give you a sense of the recipe. So the 2 houses you see on the right, the pair, are 2 of 6 that have been done, and essentially the recipe involves 240 millimeters of external wall insulation, an insulated cavity as well. I should have put that down, and I didn't. Essentially a new roof on top of the existing roof, floor insulation where possible, air tightness membranes, and then in terms of the sort of renewable technology, I mean, you can look at those first 3 items, or even the first 4 items, and from that gather they reduced the energy consumption in the buildings by about 60 to 65%. But then you still had a residual load of 30-odd%, which then gets delivered through solar PV, which you can see on the roof, an air source heat pump, a mechanical ventilation and heat recovery system, which again Sarah spoke about. The more airtight, or alluded to, the more airtight you make a building, the more carefully you have to manage the airflow. Again, just a few more pictures, pretty much of the same buildings, some happy tenants with the builder. And I guess you might all like to know, how much does this cost? I should have done this as small print, like everybody does, and you can't quite see it, but I thought maybe we should make it big print. This is all super expensive. And we, at the moment, as a council, are tendering for social housing retrofit projects with price tags for zero carbon retrofit, 75 to 90,000 pounds. And that's the price that's coming in. And that's for large quantities of buildings. And I'm not saying that has to be the price, and I'm not saying that's the right strategy, but that's just to give you an idea of what's going on in the market at the moment. So if I can leave you with a couple of final takeaways, if people, as they might often be doing these days, if people are thinking about air source heat pumps or even ground source heat pumps, I would very seriously caution investing in an air source heat pump without one of two things, if not two of two things. The first is finding a way to reduce the energy demand in your building substantially by retrofitting, by insulating, and or by having a solar PV array. And it's really ideally measures one or strategy one plus strategy two, and then a heat pump. If you don't do one of the two earlier steps that I'm suggesting, and you go straight to an air source heat pump, you're very likely to see your bills going up, even though the coefficient of performance of an air source heat pump is 2 to 3 times and maybe more that of a boiler, a gas boiler. The fundamental problem is that electricity costs a lot more than gas. So I hope that's been helpful and answers a few questions. I'm going to keep quiet now. If anybody has any questions, sorry if I ran through it a bit too quickly, but there you have it. Thank you for listening.
Thank you, Dermot. Thank you.
Thank you. So over to the floor. Any questions, anyone?
Hello.
Hello.
Hello. Can you hear
Hi.
me? Could you please repeat? We saw your little chat, but it went too fast for us. How can you tell whether you're going for the right builder? You said something about PAS.
Yes, indeed. Yeah. So there is a very helpful standard that was introduced approximately 18 months ago. The government mandated, following many years of disquiet on the subject, they mandated a standard called PAS 2035, PAS, which is simply publicly available standard, PAS 2035. And it is a professional standard required of all those advising and or installing retrofit measures. So PAS 2035 refers to the skills needed to assess and risk manage and plan a retrofit program for a building, whether that's one great lump of work, or whether it's over a period of time, i.e., a lifetime plan for the building. And underneath that sits the other standard, which is called PAS 2030, which is the standard required of the installers, the people actually doing the work.
Thank you very much.
Can I ask a question subsequent to that? Is what do the builders and the installers or the have to go through to achieve those standards? In other words, what do they have to go through to pass the PAS standard?
Well, I can speak from personal experience and advise that it is a very rigorous standard, and it requires, first of all, a fairly involved training program, which, depending on how you do it, can take anything up to 3 months. Not full time every day for 3 months.
Hang on just a sec. So I don't, because unless everybody else wants to hear the detail of that, I don't want you to say any more. What you're really saying is the people who go through them come out properly skilled in doing the things they have to do and knowledgeable. And I think it's best that we move on to any other questions.
Yep, that's a good summary.
There's a few in the chat here. Dermot, moths in wool insulation. Pamela has heard scaremongering stories. Where to refute the myth about moths?
Okay, so when some about maybe 5 to 10 years ago, I can't remember exactly when, some rogue untreated batches of sheep's wool found its way into the market at lower prices than some treated sheep's wool, and they did lead to breakouts of moth infestation. So if you choose the right supplier, you should be buying something which is treated with a natural agent called borax, which tends to essentially remove the problem of moths. But it's worth bearing in mind that you don't just have to choose sheep's wool as an insulant. There are lots of other insulants you can use which are natural, every bit as environmentally benign, possibly the same or even lower priced, without any moth risks at all, if that's still a worry.
Thank you.
Thank you. And Michael is asking, with internal insulation, I presume you're going to lose original cornices, etc.
Sarah, do you want to answer that one, because you've lived it?
Sure. The answer is yes, you do. But we still had them on the internal walls because we didn't do anything about them. So we just found an East End plasterer who'd been making cornices for years and got them copied and put them back so as to maintain the style. But yes, you do. And it is one of the problems, I would say, which I'm sure Dermot would agree with his work on social housing, is, and also privately rented housing, is this losing internal space means that you let it for less. And it's one of the big issues of why it's really something I've been arguing for a long time, is to change the rules on permitted development to allow more external insulation in places like conservation areas, because internal insulation causes so many hassles for so many people.
Thank you. Any other questions, anyone?
Yeah, there was a question from Carrie. Are there any internal insulation panels which are less than 100 millimeters that are effective?
Yes.
Aerogel.
Yeah, exactly. I was going to say aerogel is absolutely the thinnest. You can get highly productive thermal values from 20 or 25 mil of aerogel. I would warn that it is a very expensive insulant. However, if you are thinking about doing this in a conventional Edwardian home where you don't want to lose cornices and things like that, it may well be worth considering. The last time I priced it for a project I was looking at was probably about 5 years ago. And it was still very, very expensive at that time. I'm sure the prices have come down, or should have come down to some degree, but in the interim. But I would also say that you can, even using a wood fiber insulant, for example, you can still make some very meaningful impacts on your energy efficiency and your energy demand using something that is as little as 100 mil, even 80 mil. And sometimes it's not just the thickness of the insulant, but it's the rigor and attention to detail with which it's applied to your walls and your roofs. So you will have seen from Sarah's photographs, that watching out for those gaps is super important. And I would much rather do 80 mil everywhere really well than just do, I don't know, 120 mil or 150 mil or whatever it is in just some small areas. So I think you can just, it's the quality sometimes more than the quantity that matters.
Cara, may I ask Dermot a question?
Yeah, just that there was just one follow on actually from Carrie in relation to, does aerogel offer any sound insulation?
It's a good question. I'm not sure I can answer it, Carrie, apologies. I don't really know. I would imagine it does, because air is a wonderful insulant for both trapping and reducing sound transfer as well as heat transfer. Sorry.
Thank you, Sarah.
Dermot, you talked about the increasing question about cooling houses in winter. And I remember many years ago talking to you when you were investigating whether natural insulation materials delivered equally well in terms of heat insulation from keeping cold out, but performed better at keeping heat out. Did you pursue that? And what are your thoughts on that now?
Yeah, there is lots of evidence out there, scientific evidence of tests that have been carried out that show that you have a reduced speed of heat admission into a building when you use a natural insulant. So you can time by simply having external and internal fabric sensors. So let's say on a flat roof, for example, you can have 30, 33, 34, 35 degrees outside at a peak temperature in summer. And by using a petrochemically derived insulant or even a rock wool kind of insulant, that 35 degrees or 30 degrees transfers to the inside of the building much, much more quickly with low density products that have what's called low thermal mass. So if you're using a conventional insulant that most people would use, and this is a big problem for people who do loft conversions, I can't tell you the number of times people have asked me about this and asked me, what can I do? I'm boiling in summer. And frankly, the way to deal with it is to use the right high density, high thermal mass insulant, such as a wood fiber board, where the peak temperature the peak temperature admission can be reduced by 8 to 10 hours. So you can have peak temperature at 30 something degrees, middle of the day, 12 o'clock. But by controlling and using the right insulant, you will only get a much reduced temperature hitting your internal area by the evening time, at which time, external temperatures are much lower and you can live in your loft room. So yes, that's the long answer to the question. Not particularly long answer, but yeah, it's definitely worth doing that, especially in roofs.
It's certainly the case that living in a house that is insulated with wood fiber, I have no problems about heat in summer. I mean, the loft it doesn't go above 19. It's fine. And it's a lovely material. The sound doesn't bounce around. It's actually very good at sound quality and things. It's a lovely material to work with, and the company you mostly deal with them are brilliant to deal with. Personally, I would recommend it, though I would agree with what Dermot said. Whatever you do, get your builder to explain why they're recommending something.
Yeah.
Okay, I think that's it for the questions. Mary, do you want to just do a couple of closing remarks?
My remark is thank you very much to Sarah and to Dermot for such an in-depth and expert overview, and I hope everyone's going to be inspired by that. Please, if you do anything in your own home and you'd like to report back, we'd love to hear your experience, and we'd love you to be a green open home in future. And there's some on view this weekend. There are 4 properties opening, plus a unique eco building at the Meadow Orchard Reserve in Crouch End. And there are 4 more online events. The next one will be next Tuesday, the Monday, the 22nd of November, when you can virtually visit a home in Dukes Avenue. Your host will be James Tanner, and also see a green roof in Alexandra Park, hosted by Susie Holden. So 2 of our members will be opening their doors online then. Do book. I'll put the web page in the chat. Roll up, roll up. And if anyone isn't a member of the Muswell Hill Sustainability Group, we can fix that. So please join us and help our work. It's a mere £10 a year. Thank you very much, everyone, for coming. Have a good week.
Thank you, Mary. Thanks for
organising.
organising.
Once again, Sarah and Dermot. Good night. Stay warm. Yes.
Thanks very much.